So, bonjour. We now start presentation number 7. We needed 2 pages for lesson 6. So, what can we say now? Of course, the first measurements remain interesting. Kilowatt, measurement, kilowatt, so power, electrical power measurement are still useful. We may include some kilowatt or ampere. Sometimes it's sufficient on a frigorific dryer to measure. It's a small machine. Normally it's only a part of, if you have 100 kilowatt here, maybe the dryer on each of the compressors, then the dryer might be possibly 10. You have 3 compressors of 300 kilowatt that can run together, and you will choose a frigorific dryer if it is a 7 bar air around 10 kilowatts. So you see, you may sometimes be satisfied with intensity measurement, which are cheaper, and Nous makes small intensity recorders which we use. They call it Miniflex. These ones are Nous 8335 with Amflex, some big flexible measurements for intensity, and we measure also tension on this power analyzers, which is a bit dangerous sometimes. In the case of frigorific dryers, very often it's not so easy to take the tension, so we are satisfied with measuring intensity very often. And then, so we have, for energy, we have done some work, energy. We have added to our measurement project, we have added one more measurement point, which is on the frigorific dryer. What can we say about, well, we still continue to measure here either by means of ultrasonic non-invasive flow meter, or some other flow meters. Usually a venturi tube is very fit if you keep it installed and fixed, Maybe here we can measure, I don't know, by a venturi tube, to know. We measure the pressures. This is very important to have pressures somehow. Then we measure here the pressure, and it's of course interesting to measure the pressure at the output, at the outlet of the dryer, which is very often includes some filters, So if you have here P1 and here P2, it is interesting to know the pressure drop in dryer. Pressure drop in dryer usually is around 200 millibar, 150, 200 millibars, according to how you size your dryer. If you have filters, some filters to protect the dryer and some to as a safety filter in case the drain, the condensate drain, is not effective, then you may lose 1 bar. So pressure, you have here a very interesting measurement. You see how your frigorific dryer is sized, and how, but we shall not speak about filters, but it's normally you can design to maintain your filters more often, or less often. You can go up to 7 millibars pressure drop on one filter, which is a lot, So if you have 2 or 3 filters to have a good air quality, removing the oil, you can lose 2 bars in that, So it's important to know, and so we can be measuring P1 and P2, but maybe there will be more pressure points, to know the pressure drop on one filter, for example. So when we have done that, what shall we do more? At this point, we continue to measure dew point here. Dew point is interesting. Dew point is interesting in at the outlet of a dryer. It is also very interesting to measure it at the at the valves, at the final usage, if it's a usage which needs a good air quality, which is the case of regulating valves. So for quality, we have made something for quality in the measurement projection. We have one more measurement of pressure dew point or atmospheric dew point. We shall see a bit later on what it is. What does the dew point mean very concretely? Yes, it's important maybe to speak about that now. If you have some compressed air coming out of a dryer, I represent it this way, and inside this volume of compressed air, although it's a very simplified idea that I want to explain, you have some bits of water, of gas, which is H2O. Maybe you have five points of water, 5 Celsius. It's not exactly that. It's 5 units of mass, 5 particles of steam, of water. So what happens if you decide to measure? Maybe you measure here and you see that you have +1 Celsius. And and you have also, at the same time, 7 bar gauge. This is the measurement. You have always to measure at the same time the pressure dew point, the dew point and the pressure at which you measure it. And as you want to make complete work, you can also measure here the fact that you are at 25 Celsius. We are in summer in France, and today the temperature was 25 Celsius in my region. A bit warm. So what will happen if I take, when I see that, I can say that the sensible temperature, which is a temperature, and this is dew point, as the dew point is inferior to the temperature of air, of the mixture of dry air and water, then there is no liquid water possible. It's impossible. This is the basis of the theory. You may look for tables to know exactly the amount of kilogram of air. It will be about 2 grams of air for each kilogram of dry, 2 or 3 grams of water, Well, but this you will find in the tables. It's not our purpose here. What we want to say is very practically to say that when you have a temperature of 25 Celsius and the dew point temperature is less than the temperature, then you have no liquid water and no solid water, no ice either. And you note that it's at 7 bar and you measure, and this is the way some hygrometer actually work, the hygrometer with mirrors, cooled mirrors hygrometer works exactly this way. So now you are going to expand this air at atmospheric pressure. At atmospheric pressure. And the fact of expanding it at atmospheric pressure is that here you measure 0 bar gauge. This is the one change that you have made. The temperature is always 25 Celsius. Expanding air this way does not change the temperature. If you expand it by what is called in the theory the Thomson-Joule expansion, la détente de Thomson-Joule, then you produce no mechanical work whatsoever, and there is no reduction of the temperature. Believe me, there may be a reduction of temperature if you use it to produce work as on a cylinder, for example. So we shall discuss that in a while. So you have a lower pressure, atmospheric pressure, instead of 7 bar. You have the same temperature. What will be the pressure temperature? If you understand well, you have the same amount of water, the same mass of water, in a bigger space. So what is called la pression partielle, the partial pressure, is of steam, of water, is about 8 times lower, you know, because you divide by the absolute pressure. Now it's 1, it was 8 absolute bar. So you have dried your air, the concentration in steam for each unit of space, of volume, you know, is much lower. So what you measure here is you were at +1, you will be at -20 or 22 or something like that, you know, Celsius. And this is the atmospheric dew point temperature. So it is said that you can dry your air by means of expanding it, you know, without producing any work, you know. So of course, in this case, there is no liquid water whatsoever, because you are still very much under the condensation temperature, which would be well, the sensible temperature is 25, but it will start to condense at this pressure, atmospheric pressure, if you are at -20 Celsius, which is winter. In here, you see that you may have problems if your pipe goes somewhere in the pipework in a place where the ambient temperature becomes inferior to +1 Celsius. If you are in a place where outside it is -10, you know, which happens, then you will have some deposit of ice in your pipe. And why is it interesting to consider cylinders for quality? Because when you run a cylinder, you produce mechanical work which is taken out of the potential pressure of compressed air. And then you may very well have some ice forming, or some water, or some ice forming at the output of the cylinders, and then it will block the cylinders. This is the reason why you have to take very attentively into account what work is actually done by your cylinders in order to decide if you are satisfied with this frigorific dryer. You have to see if the pipe work is going outside or not, or in a cold room, you know, in some meat industry you have cold rooms, and then you have to check if the way you use air on pneumatic engines produces or not low temperature at the outlet, in which case you may have to put here a special dryer, okay? And then concerning the valves, what I can tell you already is that -20 under pressure, a much drier air would be better, you know. What people call instrument air usually is much drier than a frigorific dryer. It's adsorption dryer that you use locally for these valves, you know. So we shall discuss these aspects in the next lesson, in the next course, which will be number 8. Thank you very much.